Do you know this device, transformer, is always underestimated? You know why? Because this is a stationary device. It doesn't move. It doesn't have any moving parts. And you know, if any silent person is there in our class, let's say, he will always be ignored. Okay, the same way. But this is extensively used from generation till our electronic devices. Very extensively used, more than diesel generator and even UPS. Even inside UPS, these devices are there. So, classification and selection is very much important. Where which transformer board to be used and which is best. Okay, so we will see how we can make a best decision in terms of transformer. Otherwise, what will happen? See, what we will see, navigate options. With hundreds of transformers types available, classification system provides structured way to understand options. Structured way. This system is very much important. I told you. What will happen? We will do the costly mistakes. If you don't choose the transformer properly, we will have selecting the wrong transformer type can lead to poor performance, higher cost, and potential safety issues, even safety issues. Okay, so this is very much important to select the right transformer. So prevent these problems. Now, make right choice. Each transformer type is optimized for specific applications. Application wise, the transformer types are developed. Okay. Then future proof installation. If in future load is going to increase, then we should consider that. We should factor that in this and then design the transformer. So these are very important aspects of transformer selection and designing. Now, classification of by number of phases. First classification, single phase, three phase. Now you will ask me, what is the difference? The difference is used in two wire system, okay, phase and neutral, with single alternative voltage, typically 230 volt residential application. But I am telling you, see, there is a limitation in this. It can be used till what? Till only 100 kVA, not beyond that. You will ask me why? Why till 100 kVA single phase transformer? Now we will go to basics. What we have learned in last lecture, these transformers, because of these devices, it has become possible to transfer power from one location to another location, long distance transfer of power. See, now P is equal to what? Power is equal to voltage multiplied by current. Now, if you increase the voltage, P is constant, let's say power is constant obviously. Then if you increase the voltage, current will go down, or if you decrease the voltage, current will go up. So this device is increasing voltage and bringing down the current. That is the main purpose of this device in transmission. Here 230 volt. In single phase we have lesser voltage. Obviously current will be high. And here 415 volt or 450 or 400 volt depending on the requirement of the load. So 230 versus 415, obviously this will win because the voltage level is higher, current will go down. So this transformer, single phase transformer, winding will have very high current. You know, for just 100 kVA transformer, let's take an example, it will draw 470 ampere current. 417 ampere current. This will draw. And same capacity, 100 kVA, this transformer, three-phase transformer, a single phase will draw only 144 ampere current. Okay, 417, 144. See the difference. Because of here voltage is higher, so current is less. Here voltage is less, so current will be more. So these transformers are costly to make because high current, conductor size will increase. Okay, to manage high current, we should have a thicker conductor. So copper is not cheap, it is costly. So the cost will go up. And that is the reason same capacity 3-phase transformers are used, which are around 20% cheaper, 20 to 25%. See, 25% cheaper than this. And that is the reason we don't see this transformer in distribution system. But somewhere like in UPS or any other electronic devices, small things, so small currents can be managed, so single phase transformers are there. Even still, for special purpose machines, these single phase transformers are used. Okay, but these are expensive. Okay, and managing high current is not a joke. I square R losses will increase. Current is high, so managing heat will be a problem in terms of a single phase transformer. Okay, now you understood what is the difference. Okay, move ahead. So, selection guidelines. Just we will see the selection guidelines. Choose single phase when load is less than 100 kVA. But I am telling you, don't choose. Okay. Supplies available for residential, or choose 3-phase when load is more than 100 kVA. This is just a theory, but in practical, single phase transformers are not used. Now, classification by cooling methods. Cooling is also important in terms of a transformer. I square R losses, we have seen hysteresis losses, eddy current losses, okay, and stray. Okay, so these are losses. Cooling methods are designated by 4 letters. 4 letters. Okay, first letter, internal cooling. Okay, internal cooling means inside the transformer there is an internal cooling mechanism. Oil is the transformer oil, so that is called internal cooling. So oil, air, or K is non-flammable fluids. Even non-flammable air, in terms of dry type transformer, air is the medium for cooling, internal cooling. Okay, winding is cooled by this. Here in oil type, oil is cooling the winding, and here non-flammable fluids are cooling the winding. That is internal cooling. Second letter is internal circulation. Now circulation is happening. Sometimes forced circulation, we'll see. Okay, natural, automatically when oil heats up, it will go up, it will become lighter. We have seen in DG how it happens. Okay, so natural circulation. Then forced circulation, we use motor. Then directed, this is something new. What is directed? Yes, directed means what? Like in heat exchanger, we have seen wherever there is high heat in this winding, high heat, so exactly there oil is passed, or this coolant, whatever coolant we are using in these 3 flammable, even inflammable, not non-flammable fluids, are passed through that, and again those are coming out. Then it is going to cooling tower or heat exchanger, then again it is becoming cool. So it is only a directional flow. It is going, it is not like rotating there like natural cooling. Okay, it is going beyond that, it is taking out heat and then it is cooled down and again it is coming back. So that is called directed. So it is used for big transformers, huge transformers, high capacity transformers. Now, third letter, external cooling. Now you have seen air cooling, you have seen externally air is, then water is also used for external cooling for huge transformers where managing heat becomes a problem, then we use water. Then fourth letter, external circulation. Now circulation, so first is natural circulation, automatically by nature it is getting cooled, and second is forced. See, for big transformers you might have seen external fans are fitted on the fins, wherever that you have seen the fins, right? From core of transformer there is again fins, from that the oil is again getting cooled and going down. So here at the fins where oil is circulated, fan is fitted, so that is called forced ventilation or circulation outside, external. Now air, AN, dry type transformer, 25 to 2.5 MVA. For bigger transformers we cannot use this dry type because managing heat will become a challenge. We will not be able to manage the heat. So what is the benefit of this transformer? Indoor only, you can put inside in the basement of the building. Then minimal maintenance, because there is no oil, no liquid, nothing is circulating, it's just the transformer sitting. So it's a very minimal maintenance, fire safe, there is no oil, no flammable, nothing. So it is very fire safe operation. Ideal for offices, hospitals and environment friendly sensitive areas. Okay, so maximum of the corporate offices you see the dry type transformer. Then oil natural, air natural. What is this? This is oil type transformer, but air is circulated naturally. Okay, oil is also circulated naturally. So 50 kVA to 50 MVA, you might have seen such transformer everywhere outside. Okay, wherever distribution transformer, these transformers are there. These are in corporate, these are in your cities. Okay, so 50 to 50 kVA to 50 MVA, such a big size. Indoor or outdoor, indoor can be, but you should have a proper ventilation for that. Then regular oil testing is required, otherwise this become a risk, because if oil's dielectric strength goes down, the chances of fire or blast, even I have seen some blasts happening in the power transformer. See, most common for seen means in the paper or in news. Okay, otherwise you'll ask me. Then most common for distribution system and commercial buildings. For distribution and commercial buildings, these electricity boards always use this type of transformer because these are cheaper than this. But see, if you go to the corporate offices, this is used nowadays. This is very famous. Oil natural, air forced. I told you air fans are on the fins. So that is this. Capacity is 10 MVA to 100 MVA. Now size is going bigger and bigger. Then oil forced, water forced. These are humongous transformers, huge. You might not have seen 100 MVA to 1000 MVA. I haven't seen such a big transformers yet, but I will see someday. Okay. So major substations, oil pumps or water cooling used for transmission substations and large power plants, big power plants and transmission substations. These transformers are used.